Hello, thank you for joining today's webinar. My name is Ji-Hoon Kang. I'm a technician of MIDAS IT. Today we will talk about geometry modeling techniques. Previously on 30th April, we had a first lesson regarding on GUI techniques for beginners. We introduced to attendees about a basic interface of MIDAS. Today, we'll draw some structure using various functions to create nodes and elements, and you get to know how to draw the structure using MIDAS. Before I begin, if you see the dialog when you join the webinar, you can find the question board. So at any time, if you have any question, you can type in the dialog, and then at the end of this webinar, I will answer all the questions. I'll try the best. Okay. So today we will talk about how to draw the geometry using MIDAS. There are a bunch of functions to draw a node and element. Firstly, we can import CAD file using DXF file format, and then we have very basic functions on the node and element menu in MIDAS. And we also have automation functions for plate elements. Some engineers want to draw the slab using plate elements, which is called a shell element normally. And we have automatic wizard functions. And also, some people like to model the bridges using a table format or MCT command shell using text format. So I'll try to cover all the functions for today. And we have this tutorial file. All the slides, I will upload it to our website. It might take a week roughly, because we will edit the recordings and then we will post a blog format including this slide. You can go to our website here, which is called MIDAS Civil Academy. Here we have a bunch of webinars, previous webinars. You can click any previous webinar, then you can check what we covered, and you can download the slide, and then you can watch the recordings as well. This webinar as well will be uploaded to this website. Okay. So I'll start from importing CAD file. Let me open MIDAS Civil. Here's MIDAS Civil. Okay. So as we learned from the previous webinar, we have main menus here, and then we have worktree to check all the items which are applied to this modifier, and then we have message window here. Okay. Let me import CAD file. On the file menu, we have import menu. Here we can find AutoCAD DXF file. So if you go to this menu, then you could find import DXF file window. So we can browse DXF file. This is example CAD file. So the drawing a file may contain lots of layers. We can select desired layer to draw the structure into MIDAS Civil. As this file contains only one layer, I can select only one layer, which is 0 here. And then before we apply, notice that you can read out this message. Says when importing AutoCAD DXF file, the length unit must be identical with the unit used in AutoCAD. What does it mean by that? Let's say we select meter and click apply. We imported the drawings successfully, but if you go to query menu and query node, you can actually measure the distance between the nodes. For example, I measure here, it says the distance between these two nodes. So it says as the unit is meter, the length is around 32,000 meter, which is not make sense. So we need to import the drawing using after setting the unit as millimeters. So let me try again, and I'll measure again. I'll click the first node and second node, and it shows distance from distance between the two nodes. So it is showing same value, but as we set up the unit as millimeters, this is 32,000 millimeters. So you should be careful when you import CAD file about the unit. And also, as we have undo button here, you can always undo every action and try again. So if you make mistake, you can go back to before the action, and then you can execute anything again. Okay. So here we can see we imported 109 beam elements and 1,630 plate element. And it doesn't have any material and section thickness information because I didn't define any properties. So let me try again after inputting some example properties. Let me go to material properties, and I'll simply select the material among the database. I'll define two materials, and let me define two sections as well, having different shape. I'll set up 1,000 millimeters for height and width for this rectangle shape. And I'll try importing the CAD file again. So I'll browse the XF file again, and I'll select the layers. Then, yeah, I forgot to define thickness. I'll define one thickness as well. Let's say 200 mils. Then for the lines or the rectangle shaped polylines, and we can assign material properties and section properties and thickness. Let's try. So here all the elements have number 1 material, and all the beam elements has number 1 section property, and all the plate elements have number 1 thickness. So you can try assigning a different section as well, like this. Now all the elements has a second material and the second section. We can change it again. We can double click, let's say material number 2 from the walkthrough menu, and if you drag and drop number 1 material to the model view, then number 1 material can be assigned. You can select the element partially and then drag and drop, and selected element will have different material, as you can see here. And here's some additional information. You can follow all the steps after this webinar using this slide. As I mentioned, we will upload the slide to our website, so you can download it and you can watch the recordings as well. Here, notice that these are kind of possible type of line and face from AutoCAD, which are possible to import to MIDAS Civil. So line type will be imported as beam element in MIDAS Civil, and polyline type in CAD will be a plate element in MIDAS Civil, and face type as well will be plate element. When you import a curved line, it should be divided into multiple points. Otherwise, it will show the straight beam element in MIDAS Civil. So if it is divided by multiple points, then it will be a curved beam element. Okay. You can make a screenshot or you can download the slide afterward. We will send you the following email, including the link of the web page as well. So don't worry about slide. Okay, I'll back to MIDAS Civil, and then I'll delete everything. I'll start over using node and element menu. To delete everything, I'll double click the node and press delete key. Okay. So the importing CAD file was the first method to draw the geometry, to create node and element. The second is using node element menu. Here we have a bunch of functions. I'll try to cover lots of functions today. So I'll start over from a create node function. So here we can type an coordinate of the first node. For example, if I put the original coordinate here and click apply, then there will be only one node here. On the workstream menu here, you can see there is one node. But I'll undo it, and if I use a copy option, let's say I'll copy the nodes. I'll create the node at the original point and then copy that 5 times along x-axis, having 1 meter distance. Then it will create 6 nodes, including the original point. Okay. So as I mentioned, if you go to query menu and use query nodes, the shortcut key is F4 key on the keyboard. We can measure the distance. So the distance between the node number 1 to 6 is 5,000 millimeters. As we copied 5 times having 1 meter distance. I'll change the unit to meter to be more clear. And then after creating the nodes, we can copy the node as well. I'll select everything and go to on the node group. I'll go to translate menu, and then let's say I want to copy the nodes along the y-axis. Y-axis in this way. Sorry, in this way. Okay, I'll copy all the nodes 5 times along y-axis, having 1 meter distance each. Then you copy the nodes. As we have nodes here, then we can create element. If we go to create element, we can select the type of the element. It can be truss, or it can be tension only, or cable element. It can be compression only, or gap element. We can also make a plate element. I'll zoom it for you. Plane element and the plane stress, plane strain, and also solid elements are possible to be created. So I'll simply show you how to create a beam element. You can select the material and section. If you select the number 1 section and click on the node, then you assign the first section and first material to the element. If we select the second section and create the element, it will have a second section. Also, we have here we have intersect option. So if it is ticked, then you intersect element. You will divide the element by the node. I'll try creating element without this option. Then with the first section, then you will not intersect element. What the difference is so you can display the element number. For the first line, we have 1, 2, 3, 4, 5 elements here. For the without intersect option, we have only 1 element. That's the differences. Okay. So let's say after creating the element, you want to intersect this element by these nodes, then we can go to here, intersect element menu, and then create the element and click apply. Sorry, let me try again. Should be working. Sorry, I'm not sure what is wrong with this function. Let me try again. Let me merge this element. Now it is 1 element without removing the node. Now it shows only 1 element. I'll intersect this element again. I'm not sure why it doesn't work, but anyway, otherwise, if it doesn't work, we can use also divide menu. That doesn't really matter. We have various functions for different purpose. So we can divide the element into 1, 2, 3, 4, 5, 5 elements like this. So it is same for the intersect and divide element. Those work same. And also, when we draw the element, I'll delete all the beam elements. And when we draw the node, we can rotate the node as well. If you go to rotate node option, let's say I want to rotate this node with 18 degrees 10 times. And I'll rotate this node based on about z-axis, and I'll set up the first point as the original point. Then you rotate node copying the first node. So it is useful when you draw a curved line or the curved shaped structure. we can rotate the element as well. Let's say we have an element here. I'll go to create and create element again, and I'll rotate this element. In the same way, I'll copy this 10 times and with 18 degree about z-axis, and then it will rotate the element. Okay, and about the curved shape, we have another function. Another function which is called create line element on curve. So here we have various types, various curve type. I'll use the first type, and let's say I need 8 segment, and then I click on 3 point like this. Then you drew the element having a curved shape. So this is also useful when you draw the curved structure. You can have a look at it. You can play with all this function. As we have undo button, you can select any type and try. If it doesn't work, or if you don't like it, you can undo it and then try again. Okay. Also, I would like to show you also extrude function. So it can be from node to line. Firstly, let's say I want to make the beam element along the z-axis 1 meter each, and I need 5 elements, let's say. Then you can click apply, select the node and click apply. Then you can have a beam element. Also, you can extrude the beam element to a plate element if you use this line to planar element of type. Okay, then let's say I want to extrude this beam element along the x-axis and 1 meter each 5 times. Then you extrude. Sorry, let me try again. Yeah, there you go. And then also we have last option. If you select a plate element, we can extrude it to solid element as well. Let's extrude this along the y-axis, putting 0.1.0 5 times. Then I can create sorry. There you go. So we can create elements using these menu. After creating the nodes, and then you can click on the node to create the element, or you can extrude element from the node or beam element or from the plate element. Also, we have a grid function. If you go to view menu, you can activate this point grid, and it shows a grid in the model view. I'll zoom it for you. So here you can find grid here. Then the mouse cursor recognizes every point in the grid. So without the node, you can also create the element by clicking the points of the grid. So if you go to, if you modify the distance between the grid, the size of the grid, you can go to structure menu and then go to grid menu and define point grid. So if you type in a different distance, let's say 2.2 meters along X and Y axis, then it shows different scale of the grid, like this. And also, if you back to structure menu and grid option and define point grid, you can change the grid again. And also, if you go to UCS menu, let's say if you use XG plane, then the grid will be defined on the XZ plane. Then we can create the element on the XG plane like this. Okay. And I would like to show you the different function, which is for a plate element. I will undo everything, and then I'll go to view menu to turn off the point grid, and I will change the coordinate as global, and I'll back to node element menu. Here we have some functions for plate. Firstly, I'll try to use auto mesh function. Here, the method, I'll use node function, node type. To create the mesh, I can simply select the node here. Let's say I want to create plate elements within this area. Then click the corner of the area and then click apply. Then it will automatically generate plate elements considering the nodes inside of the area. You can also select different option. So let's say if you want to create a plate element with only a rectangle shape in the same area. To be more clear, I'll delete the node inside. We can use map mesh function and select the corner, and let's say I'll divide this into 3 times along the first direction and second direction, and then apply. Then you have only rectangle shaped plate element. So these are useful functions when you create lots of plate elements. Okay. So if you go to the slide, I'll quickly pass all the description or other description. Here we have some various options. Let's say when you use auto mesh function and by checking off or checking on the option, it shows different performance. So if you check off mesh inner domain, when you check off, then it will skip meshing inside of a certain area. If you check on, it will generate all the plate elements in the whole area. And here we have also different options. So when we have, let's say, element or node, whether to consider the node or element when we generate the mesh. We can also consider node sharing when we have multiple area to generate mesh with using the automatic function multiple times. So the nodes should be sharing, and then sometimes it is not. So that's why we have this function, includes boundary connectivity. So you can try out, as I mentioned, as we have undo button, you can follow the same step with trying a different option. That's how we can learn MIDAS Civil. Okay, I'll back to MIDAS Civil. Also, we have another function, which is reset function. So on the struct menu, we have various reset functions to generate the bridge model automatically. We have steel composite, pre-stressed composite. I'll show you after deleting all this node. Okay. So let's say if you want to build up a cable state bridge very quickly, then you can open the cable state bridge wizard, input a certain parameter, then click OK. Then you have cable state bridge model. You can modify if you don't like it. You can additionally create more elements to here. And also we have I'll show you RC slab bridge wizard after inputting certain dimensions of the bridge, and then click OK. Then you have a slab bridge with having plate elements. Also, you can modify the material and section. And also, I'll undo the wizard and I'll show you RC frame box wizard as well. It can be a frame type. This is three-dimensional model, and also it can be 2D type. If you click on two-dimensional, then it will create only the plane element for the plane. Okay, there are a bunch of webinars we have recorded on YouTube. You can search MIDAS and cable state, or MIDAS steel composite, or MIDAS FCM bridge. This is for balanced cantilever bridge. You can watch the YouTube, or you can contact us. Then we can send you the proper technical material, or you can visit our website. Okay, and also, so for today, I will show you how to use this base structure window, base structure function. So you can use base structure and beam. Then here we type like a distance and the number of copies, like this. I want to, let's say, with 2 meters each, we have 5 span. Then type the distance here and click on add. It will generate a node and assign the material and section, and go to insert and click apply. Then we have a beam here. Okay. If you don't like it, you can undo here and input after delete all. Let's say I'll input a pan span with 3 meters each, and click generate node again, and then generate the beam with on the different position as well. Let's say 1,1, then it will generate the beam element like this. And if you rotate the bat angle, let's try again what happens, then it will rotate the beam as well. Okay. After generating the beam wizard, some people like to translate the beam to generate griddless model, and or we can use this frame wizard. Let's say 1 meter distance, I'll repeat 5 times along the axis, and 2 meters 3 times for z-axis. And then go to next step. I will generate the frame for all the nodes, and I will assign the material and section, and I will insert it to the original point. Then click apply. Then you generate the frame on XG plane. This is not we want for bridge normally. Then you can undo it and try some angle under the rotation menu. Then you rotate the angle. So if you don't like it, you can type 90° on the alpha. Let's see what happens. Then you create like this. If we input this frame on the opposite direction, we can undo and input. Let's input minus 90°. Then there you go. And it shows not right, because I want all the elements be I-shaped girder. Then we can go to this element table. We can see here the beta angle shows a minus 90°. We can change it to 0° and copy this cell, pressing Ctrl C, and drag all other cells and press Ctrl V. Then back to model view. Now it shows right. Okay, this is how to utilize frame wizard. You can try out arch wizard and column wizard and plate elements, plate wizard and shell wizard as well. You can make various types of structure using this wizard. Okay, and also lastly, I'll show you how to build a model using the table and also text format. If you go to node element menu, you can see here nodes table or element table. And also on the workstream menu, if you click on right button, you can go to table menu. On the node as well, we have table menu. Let's go to node table. Here we have all the coordinates of all the node in this model file. Let's say I want to put another node on at 6, 0, 0. Then input 6, 0, 0. Then back to civil. Now we have the additional node. And also, if you like to use Microsoft Excel spreadsheet, and we can copy the coordinates from the Excel as well. I'll show you how to do it as well. Let's say you want to create additional nodes like along the axis like this. And we can copy it, Ctrl C, and here on the last cell, Ctrl V. Then now you can see a more node. And we can do it in the same way for the element as well. Let's say you can drag all the elements and copy this and copy it to spreadsheet. So this is how you can store all the element information in spreadsheet as well. And let's say I'll delete every element, and then copy the element table from Excel spreadsheet. You can paste it back to MIDAS civil like this. So this is how we can use table option. We can use a table for material or section as well. Let's say you can copy this to Excel spreadsheet and paste it back to MIDAS table as well. Okay, this is done with a table format actually, and I'll show you how to create node and element using a text format. If you go to our tools menu, we can find MCT command share function. So we can search the node and click on insert data, and these are all the node information, the node number and the coordinate. You can copy this also to Excel spreadsheet and then paste back to MIDAS. Let's say we deleted, we don't have node here in this modifier now. There's no node, and we have text formatted coordinate. I can copy this and go to MCT command shell and paste here and run. Then I'll create the node or the node. This is how we can text formatted modeling. I can put more additional nodes here and copy, including the additional cells, and paste back to MIDAS table as well. We can do this for element as well. So go back to MCT command shell. For this time, I'll search element and insert data and copy all the element information, paste to this Excel spreadsheet. And I will delete every BIM element and copy this element. Now we don't have element here, but if we go to MCT command shell and paste here and run, then it will generate elements. Okay, we can use this MCT command shell function for various functions as well, not only for load and element. We can copy the load boundary condition and so on. Okay. This is pretty much done for today. Thank you for watching the webinar. If you have any other question, you can type in the question board here. There are some questions from the audience. I'll read the question for you and answer them. I'll try the best. So, as I mentioned, a PDF file of today's webinar will be uploaded to our website. It will take some few days for us to organize all the recordings and the slide. So please visit our website here, and I want to generate cross beams at regular intervals on the curved composite girder. How to generate with single command? I want to generate cross beams at regular intervals on the I think I need to have some example models and try some functions. So if the cross beam has radius, we can rotate, I guess, the element. So you can select the first cross beam and then input the radius of the curved bridge, and then set up original point. Then I think you can make the cross beams for the curved composite girder bridge. Is it possible to, here's another question, is it possible to create the whole model, which including the loading, tendon, and vehicle combination in text, where in this scenario, Rhino gas chauffeur can help to do this? So, well, MIDAS offer provides text formatted modeling using MCT command shell, but it is slightly different from the Rhino. I guess it uses certain type of sort of computer language, but we have some fixed format. So if you go to our online manual, you can press F1 key in the MIDAS. Here we can go to appendix. If you go to MCT command list, it shows what things we can consider we can use text format. So let's say tendon. We can type text format of the tendon profile, and you can insert this command in MCT command shell. And also, I'll show you. So let's say I open another model, and including tendon or loading and boundary condition. So here we have many of load cases, and also we have construction stage and construction stages and boundary conditions. If you export it to MCT file, let me save it on the desktop. It will take a few seconds. We can export the model into text format like this. That means you can edit the data with text format and apply to MIDAS. So you can put some additional data for the loadings, for the tendon, whatever it is, and then bring it back to MIDAS. If you want to input the text format, not only for one particular function, if you input all the things at once, you can use import function here, MCT command, MCT file. Then it will bring all the things. Here we have load cases and sections and construction stages, boundary conditions, and so on. Can you copy load cases and combinations from one model to another for various geometries? It depends. It depends the model. So because the loadings basically, I'll go to table format. So here you can see, for example, if you bring the element beam load function to another model which has a different geometry, it is harder to say it is possible because each loading contains element information. So the load cases have the information about the element number to be applied. So if two models have different element number, if you bring it to a different geometry model, then it might show awkward loading. So here's another question. Sorry, your answer is not clear at all. Please demonstrate the generation of cross beams on curved composite girder. It will take time for me to demonstrate here because I don't have curved composite girder bridge model at the moment. So please visit our global technical website and upload question. Then I'll prepare one example model and show you an example how to do it. Or you can send your curved composite girder model. Then we will kindly answer you how to do it. I'll try that out. Okay. Does MIDAS contain VBA editor? Actually, we don't have a VBA editor, so you can. I saw some people using VBA editor, VBA tool to generate all the text. So we have like one more step to use VBA. So using the VBA tool, you can create some macro or software to generate the text format. After generating all these text, you can bring it to MIDAS Civil. I hope this can be your answer. Can I define a crossbeam like box girder section by using Excel sheet and the coordinate? To generate the element, firstly, we need to have the node first, and then when we generate the element, we need to include the node information to be connected each other. So if you are sure about the node coordination, the node numbers, you can also generate the element as well, whatever the location is. Why this manual is few years outdated? Sorry, I'm not sure which manual is you're mentioning. Can we have a more detailed webinar on use of MCT command share for modeling and analysis? For today's webinar, in fact, I tried to cover the basic functions for the geometry. So I slightly just showed you just basic function, a very small part of MCT command share. But we may consider it as the future webinar. I think many people wonder about how to utilize MCT command share very well. And also, if you we have another tutorial actually. We have one example of how to using MCT command share. Maybe I can send you the MCT command share tutorial by email later on. Please email us. Let me show you our email address. You can visit here MIDAS Academy page, or it would be better if you have any question on MIDAS Civil. If you can visit our Global Technical Center. For general question, you can contact here this info at midasit.com.